Hello, guys. Welcome, and thank you so much for joining us today. All right, we're still going to give it just a couple more minutes to see if anyone else is logging in. But while we wait, Prolim is a leading PLM, cloud, Mindex, and digital transformation solution provider. Now, with our global footprint and our level of expertise in all of the latest technologies, Prolim can partner to speed up your digital transformation journey. If you are not familiar with all the greatness that Prolim is, please, by all means, go to our website, prolim.com. All right. So, guys, we're going to give it, as I said, just about 2 more minutes, maybe three, just to make sure everyone has a chance to come in. And as always, we will record and send this out either later today or tomorrow. All right. Thank you guys for your patience. All right, guys, it is 3 minutes after, so let's go ahead and get started. Our tech talk today is on wave geometry and Interpart link in NX CAD. Now, as you have questions on this topic, we invite you guys, go ahead, unmute your mic, ask Bryan, questions live. You can enter them into the chat if you would like. And then, of course, we'll also take questions at the end. So it is truly whatever makes you happy, whatever works best for you. Now, our presenter today is Bryan, and I know a lot of us are very familiar with Bryan. He's in our Cincinnati office, and just a quick overview of him. He is a senior application engineer. He has extensive experience in various different CAD programs. He's got over 20 years experience working with NX and Team Center, and he has truly an excellent background in mechanical design, tool design, free-form modeling, GD&T, stack ups, you name it. So Bryan he is one of our favorite resources. So thank you very much for joining us, Bryan. This Tech Talk is now yours.
Thank you, Misty. Hi, everybody. For you that don't know me, I am Bryan Fisher. She just talked about. Today's webinar or tech talk is going to be on wave geometry and interlink parts. Just a real quick background on myself. As Misty was saying, I have over 25 plus years experience within X and Team Center. 15 years as a designer in the aircraft industry, 5 plus in the medical industry, and then for the last little over 6 years now, I've been a senior NX CAD application engineer here at Prolim. A little bit of my education there. So on the agenda today, we are going to be looking at wave geometry usage. I would like to hear from many of you exactly how you use it. But before we get to that, I'm going to go in and I'm going to talk about designing context, part and process, control structure. Then we'll get into the dialogue, what's the options are in the dialog box. Additionally, we'll be looking at promoted body versus wave, Interpart browser, and then a brand new feature called Interpart Navigator. This is brand new to the 2412. So I know most of you guys will not have it, but I do want to show it and show you guys the future a little bit of what you will see with wave geometry. Now, this must be turned on in the early access features for it to take place. And I see that there will probably be more advancements in it, on the next monthly update or rev or version. But before we get into that, let's go ahead and I'm going to look at some of these notes that I have up here. So when you create or edit wavelength feature, you should kind of consider the following. And I will show examples of these throughout this presentation. You should evaluate the downstream impact and avoid creating links just because you can. No reason to overcomplex stuff if you don't need to. Link bodies are added to the model reference set, so the mass properties are affected during these calculations. So if you go and you look at this particular assembly I set up, I have my wave geometry part, my wave context independent. We'll get into that here in a few also. And then the wave 2. Wave 2 is the normal way that you would set up a wave geometry part. You can see here my mass is double compared to these other ones. We'll get in how to avoid that and what we can do on that also. Just know, traditional method, you will see double the mass. As we look into this again, the assembly constraints do not duplicate with linked objects, but they do determine the position. So if you need to move a body within a linked body within your part, there are some things we need to do to be able to do that. We'll have to turn on some options within the dialog box. We'll do that here in a few moments also. When you do add linked objects, I recommend that you go in and you change the properties and you actually put a feature name to them. For example, linked face underscore base plate. It just makes it a little bit easier for somebody that's following you, or if you're on a big project and you have to come back to it later, you can kind of remember, oh yeah, that's where I got that linked face from. There are other methods to find it, and I'll be going through that throughout this presentation also. Additionally, consider what geometry you select and bring over. If you only need an edge, why bring a whole body? If you only need a face, don't bring the whole body, and so on. Your load time can be considerably longer if you add a bunch of unneeded waved information. Now let's move in and start looking at some of the usage of wave geometry. This is the most common, designing context. This is what I've done most of my career. I was a tooling engineer for a long time. I did a lot of CG bars, dollies, build stands such as that, such as what you see with this blue plate over here, tooling and fixtures. And another thing I used a lot of was left-hand, right-hand parts. So what is designing context? Well, it's the geometry in one part that references the geometry in another part to form an associative relationship. So for example, in this tool and fixture here that you see, I have an engine hardware. I have a bolt pattern. That bolt pattern is determining the bolt pattern in my blue plate and also the nut plates I have. Now in that particular assembly, I did some things incorrectly on purpose that I'll be showing you guys how you can accidentally get broken links and some other things that you may need to look into. The next area we want to look at, part and process. This is an old method of being able to do staged modeling. This was prior to stage modeling, also prior to design groups. I'll talk about them when we get into this portion of it. Now, this brings me back to my very early days when I was a young engineer, and I started actually in the CAM side for a very short period of time. And when I was top modeling way back when NX was UG, basically what you would start off with is a block. So you would look and see what size a block you need. So think of it, as your material. How much material? What's the stock size I need? Then you would go and start cutting material away. So you'd almost think like you were manufacturing it. You start off with a block, you start subtracting here, and so on. So this here is more or less stage modeling, but there are still a lot of people that use this method. This method, you start off with your block, then you got your next operation, and so on. There is a nice video out there. If you go and type this in and Google it, you will find it. It is a video that's a little bit old. It's a Siemens video. It's from 2013, but it does go through this process real nice if you choose to go and actually utilize this process for this type of ability. In the next area, we're going to talk about wave engineering, also oftentimes called control structure. Now, the diagram I show here is actually the new Interpart Navigator. I show this because it explains this very well. And I'll get into those, details here in a second. But let's just look at this and see what it exactly is. Well, its controlled structure is your very top level. That is, it has some key dimensions in it, maybe datums, maybe interface of a product. So let's say a vehicle here. Maybe you have some restrictions. Maybe you have a height restriction, width restriction. Maybe you're looking at some length restrictions. So those particular datums and restrictions and stuff like that are in your top level. You will then go in and actually take these particular datums, sketches, points, whatever they are, and you will break it out into sub-assemblies. So you can see here I did a lower body, I did FOD, and then I did an engine component. So what you can see that I started off with 22 particular areas that I was concerned with. I dropped those into each sub-assembly. So you can see the number 7 here, and 8 here. From there, I can take, for example, the lower body here and have my start parts. So I can have multiple start parts down here. Now, the way this works is I then need to go in and create a part to start off with. So this is my toe pan. My toe pan then would come in and bring in the FOD start part, and I wavelength that back up to here. So if we go back to the start here, you can see if we follow that tree, it goes all the way up to the CS vehicle. Now this does take some naming convention, and it does take some areas where you will have to actually go in and have some administration work done. So you may have an administrator that actually, controls this information. Now, I've seen this done when I was just recently in Australia. My customer, they did this, and this file was huge. And they had multiple different sub-assemblies and everything else. They had it set up nice except for one step that they were missing. When they were creating their part file, they were actually bringing in the top level, not the start part, and they would have to go weed all the way through there. Due to that, their load time was very, very long. So you want to watch that when you are going in there and looking at that. So, with that being said, so far we went over the agenda a little bit. I've talked to you about the wave geometry linker notes, stuff to look for. I showed you 3 different manners to go in and create wave geometry and its usage. So before I go any farther, does anybody have any questions or comments of how they use wave geometry? Okay. What I'll do now is I am going to go back to this particular assembly right here. And I am going to open that assembly up, and I'm going to show you some things to watch out for when creating wave geometry. Once I do that, we will then start going into more of the dialog box and talking about these options in here. Go ahead and get NX open here. So here I am in the brand new version of NX. This is 2412. I'm going to go ahead and open up my build stand here. Now, when I open this up, it's going to ask me to update. That's no big deal. It's an older file, some of this is. And I have my bolt here that's actually part of a part family. So, when I'm looking in here, how did I create this particular assembly? Well, my nut plates here are actually driven by wave geometry, and so is my mount. But I'm going to focus just on the nut plate right now. I'm going to go ahead and hide this other material, and we're going to look at this. So the first thing I want to point out when dealing with wave geometry, your assembly load options out of default are minimum load, lightweight. If you know you are dealing with wave geometry and you often have it in your parts or your assemblies, I recommend changing that to either fully load or fully load lightweight. Fully load would load everything, and it takes a while at times, especially if you have bigger assemblies. But fully load lightweight, it will actually display the parts as a facet body and bring in all the other material, the data in the background, because that's what we're concerned with. Right now, I'm going to leave it as if it was default, and I'm coming in And I'm an individual that really is new to this software, let's say, or this technique. So an individual comes up to me and they say, you know, the engine hardware there, we want to come in and actually make a change to the engine hardware. Now, first off, how can I tell that this is fully loaded or not fully loaded? Well, it's really easy. All you have to do is over in your assembly navigator, look and see if there's a box around it. Notice there's a box around the hex bolt. That's fully loaded. These other ones do not have that. So that's telling me they are not fully loaded. It's important to have one fully loaded because that information drives that nut plate. Now, I'm an individual, you know that, going in here, I'm going to make my engine hardware change. I'm going real quick. I have somebody, you know, behind me yapping at me that we got to get this done, you know, so we can get it out there today. So I'm not paying attention, let's say. I come, okay, they want me to go in and make a change to the engine hardware, and we're going to dummy proof this, or maybe we're going to put a hole and offset it so that we can put it, you know, use as a datum. So we come in here and I'm going to go make my change. I'm going to go pick this hole right here. And I'm going to go and move this here. And the next thing I got to do is pick my vector. Oops. Let me do that over, guys. I apologize. I went a little too quick there. Pick this here. And then we got to go find our vector. I fat fingered it last time. I meant to hit this vector here. And we come in and let's just say, we'll go 2 degrees. So if we zoom in, you can see there that that's going to change by that 2 degrees. I say, okay. I come back up to my build stand. I go and save it. And I tell them, yep, I made that change. All's good. Well, somebody else comes behind me and they have the same load options I do. And they come in and they're going in there and they do a check and they're like, Brian, we got a little bit of a problem. That hole didn't change on that nut plate. Oh, dang, I'm sorry. You know what we forgot to do? I'm going to go ahead and unpack these real quick, and I'm just going to, I forgot to load that fully. So as soon as I come in here and I right click on that sucker and I come in and I say open component fully, boom, you see that that changed. Now, I made another mistake, though. When I was looking at this, I assumed that all these nut plates were going to be the same. Well, they're not going to be because we got one of them that's having an offset hole now. So when we come down here and we look at one of these other nut plates, oh, dang. We don't even have a hole there. You know, that hole's actually offset from where it was. So what do I need to do? Well, I need to make that a unique part, right? Well, I'm in the assembly here. Nice thing in NX here is I can simply come in, click on that nut plate there. I'm only going to focus on that one. I'm going to right click, and there's a nice little thing called Make Unique. So Make Unique is going to take that information, I'm going to change a name to it, and I'm going to go and update it. So I say Make Unique. I say Name Unique Part. We're just going to call this Bryan plate. We enter that, and we said, all right, everything's linked still. We're good to go. Let's go ahead and say OK. I come in and I apply this. I'm not going to save it right now, but boom, comes up, and guess what? It broke the link. I'd be dang. So now, when I'm looking at this, I still have that same issue. Well, let's go ahead and look at this part here. I'm going to make this my work part real quick. And let's go in here and look at what happened. Oh, my linked face got broken. So I need to relink that face. Well, I'm going to go ahead and turn some of this off just so I can see a little bit more what I got going on here. And I'm going to look at this and say, well, how do I relink that face? We come over here, make this my work part again. Come over to my part navigator. I'm going to double click on this. And it takes me into this geometry linker. Now, this is a pretty easy one to go in and make that change. All I got to do is pick that face, right? If you have a more complex one, however, you do have a replacement assistant here. It's a wizard that helps you walk through stuff. But for right now, I'm just going to go in, though, and I'm going to pick that face that I want to Go in there. I do have options. I could extract it without holes. Could inherit material. Like I said, I'm going to get in some of these other options here in a little bit. But just for right now, I want to say okay. Now, when I come back into my part, I do have my linked face, but I have some areas here of concern. Let's go ahead and open that part in its own window and see what's going on here. Well, because I created this, I know what happened. In my sketch, I actually used the old linked face and I included some of those edges and holes and stuff like that to it. So what I need to do now is I need to go back in my sketch real quick and just take some, notice it says external inputs. This is where I'm saying if you're using wave geometry, you kind of got to think what can affect this. How can this be messed up down the line if I'm not really thinking? Well, in this case, I wasn't thinking. I thought all these 4 nut plates were going to be the same, but me being an old engineer should know better and say, well, there may be an offset hole that they want dummy proof or use as a datum later on. Well, I didn't do that. But how can I fix this? Well, it's pretty easy. I'm in the new sketcher here, by the way, if you guys can't tell. I'm going to select my curve, select my reference curve that I use, and I'm just going to simply come in here and do a few things real quick. And a real quick trim right here. And close out of that. And now we're back to having a nice little part that's everything's wave geometry linked back together. Now I am going to go back into this particular assembly again, and I'm going to show another mistake I made. I'm going to go ahead and turn these nut plates off. Let's go ahead and actually pack those, turn them all off. And turn mine off here. And we're going to turn the weldment on. Not the weldment, I mean the mount. Now this mount here, if I go ahead and make it my work part, what we'll notice is I have a linked face that's broken. Now, that linked face, I didn't even know, let's say I didn't even know it was broken because the way I created it, I thought everything was nice. So how did I create that? Well, let's turn this off and walk through them steps. When I went in to create this, the first thing I did, I came in and I said, okay, well, I know I need some wavelength geometry. I got a face here. Here's my face, wave geometry linker. I come back here. I don't need the whole body, right? I just want that face. So I come in there, I select that face, Associative, and I say, okay. So if I turn that off, notice what we have now is just that wavelength face. It's in my part navigator here. Everything's linked. So at that time, I said, all right, I want to start my part. I want to create a component. So, you know, I'm working in the context of the assembly. And then I'm going to break it out. So I come in here, I say, new component. I go and select my object. I name it, and I say, okay. So now I have my face that I can use to start creating my base. However, if I go in here and make this my work, and I come back over here, notice we have some issues. So I need to redo that real quick, guys, because I did mess up on that too. I apologize. I had something on that I shouldn't have had on. Let me go ahead and delete that real quick. Went a little too quick there for you guys. Turn it back on. I'm going to go with my wave geometry linker. I had this checked, and I don't want that checked right now. That's for later on. That's one of the options. My bad. I'll go ahead and reset my dialog. Come in there and get my face. Notice it is not on default. So at this time, I'm going to go and pick my face, and I say, okay. Then I come in, I create my new component. Knowing I want that particular face, I grab that face, and I say, okay. Now let's go back into my model 2. Now you'll notice that the face is broken. So there's 2 ways we can avoid having that broken. You guys already saw the first way. And I'll explain what that does. I'll redo it for you. So come in here. I'm going to go ahead and delete this again and just redo it for you real quick. So we have our model. I want to add a component because I want to add that plate. The first way I did it, I showed you guys, I went into Wave Geometry Linker and Face. But under here, there's this thing called Make Context Independent. When you make context independent, you do not have to have the component of the parent file in your component file. And I'll explain that a little bit more when we get here. But right here, when I go ahead and select that, and I go in here and say OK, and then I create a new component, you'll notice the linked face is still linked face, not broken. So that's one manner you can create that. The other manner you can create it is by creating a new component. I'm not going to select any objects. And then from there, I now have my Model 4 in here, and I want to come over to my Wave Geometry Linker, reset my dialog, so it's as is default when you open it. Notice it's not checked. Then I come in here and I select this, and now if I go and look at my model, I can come in here and get my wave geometry, pick my face that I want, and everything will be nice and should be the way it should be. Any questions on that, guys, so far? Any comments? Okay. So when you're in here and you're using wave geometry, like I'm saying, you have to have a process and you got to think it through. You can easily have broken links, or you could have a situation like I had here with the nut plate, where I'd have to go in and make some adjustments. Let's go back into my PowerPoint real quick. And let's go in and start looking at the dialog box and looking at these particular options a little bit more than what we were just on. So the first thing we have in Wave Geometry Linker, we have body, we have curve, we have face, things like that. Each one has a little bit different settings. But for the most part, most of these settings react in the same manner. As I just showed you, you have two ways and two methods to create these wave geometry now. So you have context independent, and then you have the old school way of putting the component in there and bringing it in. What I'm going to do now is I'm going to recreate these two ways of doing it and show some of the benefits and some of the things we need to watch out for when we're doing this. We go ahead and close these. And let's go find my first part here, my geo part. And let me go ahead and open up one other part real quick. And this part here is going to be my wave context, and this one here. So the wave geometry part here, this is my body that I want to wave over. The old school method, such as what I did here, is you would come in, you bring in the wave geometry, and you link to that. Now, as I stated before, one thing we need to watch out for is the mass. If I come into my analysis and update this, notice it's double the mass. That is something you need to watch out for if you're doing it in this method. So let's recreate this one real quick though, and then I will show the other method. So here I am inside my particular body here. I'm going to go get rid of notes. All I got is my datum. This is my body that I want to go in, my part file that I want to go in and actually bring in my WaveGeo. Going to add a component. We're just going to bring it in. Now I have my WaveGeo in here. What I want to do from here is I want to link this back to here. So I have my associativity on. Let's go ahead and hit body first. Associativity on, inherit material, and copy threads if I had any threads. I choose my body I want to bring in. Now, if there's multiple bodies, you have this feature here where you can separate features for each body or create for all one body. The reason I've seen this used is in weldments. Maybe you want to come in and actually bring in everything as one body. That would be your weldment. However, I recommend promote body for that, and we'll talk about that a little bit later today also. So from here, I'm going to say OK. Now, if I come down here, I have my linked body. So this is the traditional method that most of us used for a long time. Now, if we come over to the context independent, what you'll notice is we have a linked body, but if we come to our assembly navigator, there's no wave geo in here. So how did I go and get that particular wave geometry? Well, in the past, you had to have your component in there because if you didn't have the component, you could not go and pick a body to bring into it. However, I'm going to go ahead and delete this and redo it real quick just to show you guys. So here's my wave geo. This is the body I want to wave. This is the file I want it to wave into. What we need to do is I simply come over, split my screen, come into Wave Geometry Linker, turn on Make Context Independent. I'm going to come and select this, and I'm going to OK it. So now when we look at that, I did not have to bring in that particular body to go in here and do it. Now, what do you guys think is going to happen with the weight, though? Now you get the correct mass because it doesn't have two bodies in there. Make sense, everybody? You guys are awful quiet today. You can speak if you want, guys.
All right. I actually have a quick question.
Yes.
When you're making it context independent, are you like what exactly is going on with that? Are you breaking the associativity? That's the only question that I have.
No, right here's my linked body.
Okay.
How do I know it's associative, what it's associative to, though, right? Let me go ahead and close all these, and I'm just going to open this one by itself, okay? So let's go ahead and close all that. And I have my wave context independent from part. So see, it's a linked body right there, right? Up here, you see there is no component. So the thing to watch out, and this is where I was saying you may have to have some administrative work. You want to have people that are controlling those wave geometry parts, lock them down, as soon as possible. So that's where, there may, need some communication going on. Because right now I'm working in this particular wave context independent part, and I don't have the parent loaded, right? How do I know? Well, if I look over here, right away, it's telling me parent part wave geo not fully loaded. If I go into my part navigator, I get the same thing. Source not found. So if I look here, let me expand that a little bit. Parent part wave geo not loaded. That doesn't mean it's out of date, but we don't have no way to know it's out of date, right? Because it's telling it's not loaded. Another way we can check on that is if I come in my assemblies and we come over here, we have our Interpart link browser. This browser tells me right now what's loaded. It tells me the parent part's not loaded though. So a good technique and a good method recommendation is to load that part just to make sure. Now, if you're in Team Center, you could simply go in there and do a search on that part and see if it's, released for share or released for issue. Then you can pretty much say, okay, I trust this and let's move on. But in this case, we're in native. So what would I want to do? Well, let's go ahead and open that part up. So it's the Wave Geo part. And let's see what happens now. When I come back over here and look at my Wave Context Independent and we look at it, notice the info went away. Notice the out of date, there's no question mark. Notice over here in the Part Navigator. If I go in here now it tells me it's fully loaded. So when dealing with wave geometry, you can see why it's important to have stuff fully loaded if you're relying on it to control other features. Did that answer your, that was Jason, correct?
Yep, that was it.
That was what you were looking for, right?
Yes, sir. Thank you.
All right, not a problem. So let's go back into my PowerPoint for 1 second. Now, when you're doing this make context independent, you are limited to these features right here. Just know that, okay, when you're going in there. Let's go ahead and move to the next area here. So this is finding parent when using make context independent. There's 3 different methods that I just showed you guys. I did not show you one of them, which is this one here. So you have your assembly navigator. You can see there what it tells you. You have your part navigator. You also have the, what was that I looked at? I'm sorry. My mind just went poop for a second. You have your Interpart link browser. Now, there is an additional one, and this is only in 2412 that I talked about. And it is called the Interpart link navigator. This is the little tab up here. Notice when I'm inside this particular context independent, I don't see no diagram, nothing showing up. Now, this is the first release of this particular tool. I'm sure there's going to be some enhancements later on. As you guys know, you can put an enhancement request in, and I'm sure this is going to be something people mention. Because at this time, you won't see it. If I go over my Wave Geo over here, you don't see it either. However, if I go in and I open up my Wave 2 part, which was done in the traditional manner, what you'll see in here, it gives us a diagram and shows us exactly what's going on. Now I'm going to close everything again. I know I'm doing a lot of close and open, guys, but this is just because with the wave geometry, I try to break stuff on purpose just to show you guys how we can get stuff done. So I'm going to go into wave context independent again. This time, again, we get our question marks because I don't have the parent loaded. Now, if you don't have that column turned on, let's say, or it's collapsed and you don't see it, and you're working away, and you go in and say, well, I need to do something at link body. Oh, it comes up right away and gives you an alert down here telling you the parent is selected, but the selection appears empty, the dialog, because the parent part is not loaded. Again, we can look over here at parent information, and it tells us what the parent part is, what object we're bringing along, and then it tells us it's unknown. So what would I simply do? Well, I go open that Wave Geo part and be able to move on. Make sense, guys? Am I losing anybody? Is everybody following along good? All right. Has anybody used any of these features, such as the context independent or any of the navigators that I showed? All right. Y'all sound like you need coffee. All right, so we'll move along now and get into some of these other areas here real quick. So the circular reference. How many of you guys have come across this? If you use wave geometry, it is easily, you can easily get yourself stuck in this loop. So I'm going to go open two parts here again, and we're going to look at how that occurred. I have my wave geometry. I should have left the other one open. That's my bad, the wave context. And what I'm going to do is I'm going to create a circular reference error on purpose. Now, how can that occur? Well, let's say an individual, naming convention is really common. Maybe there's, you just use numbers and you have two numbers that are flipped or something like that. You open up this part thinking you are inside the parent part. You're moving along quickly. You're just going, okay, I want to put a hole here. And then I want to go back to my other wave geometry part. And I actually want to take that particular hole. And maybe I want to use that face, the edge there, to create a hole in this one. So I come over and I say, okay, well, I can use wave geometry. Cool. So I come over, I say wave geometry linker. I come in here, I say I just need a face. I go and I pick this face over here. Let me get a second here. Edge, I'm sorry, composite curve. I'm going to go pick this curve. And I'm going to come in here. I want an associative. And yep, that all looks good to me. I'm going to say okay. And then I close this part. And I'm like, all right, now I can go and create my hole just using that edge. That's going to give me my location. I come in and I say, okay, we're going to go and get us a hole here. And at this time, I'm going to come in and take and use this edge for my hole. And right now, it allowed me. But if I come in and I reopen this part, you're going to get this error right here. Does anybody know why we're getting that error?
No.
So what it comes down to is the following error occurred during an update. There is an object which depends on itself. This was caused while updating the object link composite curve. What happens is this body here controlled the body of the other part. You got a circular dependency, exactly, blah. So that body, then when I tried to go and update it, it actually says, wait a minute, this body's controlling that body, and this curve's controlling that body. So it's a circular loop, and it doesn't know which part's the parent at that time. Make sense? So when you're going in and you're making these particular type of changes, make sure you know what the parent part is. Because if I went in here and I had that part in here, you would see that would be like a big loop going around in a circle. All right.
So, Bryan, does that happen frequently?
Yes.
Okay.
It happens when you get into more complex wave geometry parts, such as the one where I was saying my customer in Australia, they had multiple sub-assemblies underneath each other with all kinds of wave. And if they did not know where that wave was coming from, they could be in a parent part and try to link it back to it. And once you try to put a feature to it, you can get yourself caught in a loop. It also
Gotcha.
happens on the assembly side if you have constraints. So you have a sub-assembly, and let's say, for example, you have wire diagram going on, or wire harness going on. And you have a component within that wire harness, a connector, that is used to create a link. And they go to the parent file, and then they try to take that conductor or piece, and they try to constrain it to something else. It's going to tell you can't do it. You get circular reference. It's just a big loop. Just think of it as a loop. All right. Use display properties of parent. So your mass property can be different in a parent and a child if the material properties are different in part files, such as model preference. What I'm going to do is I'm going to create brand new parts here, 2 brand new parts, real simple parts. And we're going to come in, create a part. And when I create that part, first off, I use the start part. So where's the start part? Well, the preferences are what controls that start part. So at this time, my density is 0.2829. I come in, and I'm just going to create a simple block. And if we come up here and we look at our analysis, we see what our mass is. Now I'm going to go ahead and create another part, new part. And when I create this new part, we're going to act as if I had a different start part with a different mass. So I'm just going to put the density to there. So at this time, this individual's working in here. And they're like, you know what? I want to wave that part over. So they come in, they go in their assemblies, wave geometry. They come in and they say, I want to wave that whole body over. They have inherent material off. So what's the first thing we got to do though, guys? We got to split the screen so we can be able to pick that part. So let me go ahead and split it. Go and wave geometry linker. My body, I have this turned off. Maybe I had it turned off earlier and didn't realize, right? So then I come in and I pick my body and I say, okay. Now remember, over here, see our mass? 113.16. Remember, our density is different in this part and this part. But it's the same body waved over, right? So I come over, wave that over like I just did. Update. Look at the difference, guys, in that mass. Same body. This is waved from Model 1. How do I know it's waved from Model 1? Well, that's a pretty simple thing to go and look at, right? Waved from Model 1. So if you're using different start parts, make sure you have the right mass, or you may be able to bring in the wrong, bring in the correct geometry, but your mass weight may be off. Now let's go ahead and do something else here. If I came back over here to this link body and I said, okay, well, dang, that's off. I actually want this to come in and inherit that material. And we say, okay. And then we come back over here and we update our mass. Notice now the mass is correct. So there is a way to fix it if you guys notice that your masses are different. Now, additionally, if you change the body color, I'm just going to come in here and make this body color a different color real quick. Oh, thought I inherited the properties, right? When I had this here, I told it to inherit. I did not. See, I did not have use display on. Let's go ahead and say use display and say okay. Boom. And you'll notice it changes that color. However, once you have that on, and if it's only a change of color of the body, it will not change that color. However, if I came in and I made an update to it, such as a hole, a blend, or anything else, notice the color changes. So these are the things I'm talking about when I say it's a powerful tool, but you really need to pay attention what options you have on. So as you can see here, you can inherit the material. Again, though, because I did not do it in the in context method, I did it the actual old school method, you see my mass is double. If we move along, you can fix it at a timestamp. At any time, you can go back and go in and actually turn off fix a timestamp, and it will update though. Now I'm going to go through some of these kind of quick because we only got like 8 minutes left, but I do want to show these, as we go through. And if needed, we can always, have a side meeting. If you guys need one, you can always contact me, or we can always do a, part 2 of this if there's certain areas you guys need to look at. So moving objects. This here is where, when it's a wave geometry, you actually have to turn something on. So let me go back in my NX real quick on this one. And I'm going to come in and say, let's go ahead and try to move this particular part. Inside here we have, let's go to the tools, say move object. I'm going to turn that off. Let's go ahead and put it to what it is when we go in. And at this time, this is default when you go to move a part. So I'm come in. Notice right away it tells me one or more of the selected objects of the parents belongs to a position independent. So what I actually need to do is turn on associative, and then it allows me to move it. I got to turn off move parents. I'm sorry. You got to turn off move parents and turn on associative, and then it allows you to move the part. Now, curves. With the curve, you have 2 different methods, as I just showed. You can select a component, have it as a part of your tree, your assembly tree, or you can go in and context independent. Some of these are just repeats of, the stuff that we just saw, for the options. Now, this one here, when you're in curve, though, if you have 2 self-intersecting curves and you want them to be waved over, the default is that is turned off. You would have to go in to your dialog box and turn on allow self-intersection. Then it will allow you to bring in a curve. Additionally, if you're dealing with any advanced curves, here are your options on those. So if you're dealing with splines and you're looking at degrees and maximum degrees and segments and stuff, just know that this information is in the help within NX. The next one we look at is point. The point over here, you can actually turn on a draw line between 2 points. So in this case, I picked 2 points. They could be on edges or anything like that, and it will draw a line between them. On this one here, wave geometry linker for faces. The faces here, you have an option to extract it without holes or with holes. So as you see here, I created one here that had a hole in it. Notice the face there has a hole. And then I went and selected another one and I turned off extract without holes. And you can see it's a face without a hole, even though the hole was there. If we look at our geometry linker here for our wave face regions of face. In this case, I have the same assembly, but I have 2 different parts at the top. One has a through hole, one has not a through hole. This example here I'm showing right now is without the through hole. I select the same faces, and you'll see here the difference in a second when I go to the next slide. When I select this, you can see these are the regions it gives me. However, when I do it with a through hole, you can see I get slightly different results. Wave geometry linker for mirror body. This is more used for the left hand, right hand. This is pretty self-explanatory. You have your one model here. I put a plane down here where I want it to be my center. I simply go in and either select my body or components, depending on what you have, and then it will go and mirror it over. This is another one where you may want to go into the feature and turn it to be all one or just individual parts. Depends on what you're working with and how you're working. Promoted body. This is the one that can get a lot of people. Promoted body has its place still. you don't have as many options as you do with wave geometry. Here's some of the restrictions you have with it. These restrictions can be found in the help document. But promoted body does have its use. I'm going to quickly open this one up and look at it, and it will be the last area we look at, guys, and then we can open it up for questions. We only have a few moments, so I'm going to do this real quickly. Let me go ahead and close these parts. And I'm going to go open my promoted body, and we're going to look and see what we have going on. So I've already went in and I promoted a body. Once I promoted that body, I went in and I created these features: hole, hole, and edge blend. Now the nice thing about promoted body, I'm going to go and update my mask real quick. And what you'll notice is the mask is correct. This was the master, and this was what happens when I put the holes and blends in. Now what you'll notice also, it tells my parent master not fully loaded. Let's go ahead and open that and just fully load it. Well, when we do that, now it looks like it's up to date. Now this is what you got to watch when you're working with promoted bodies. When I go in and I say master, make work, you see how it has all my promotion stuff done to it. It has all the promotion stuff, so the holes, the blends, and all that. Now let's take this master and open its own window. Look at the difference, guys. Put them side by side real quick. And I'm sorry if you hear my dog barking. She's 17 years old and don't know when to shut up sometimes. So what you see here, though, is this component is still the same component that's in here. Notice master, master. But when I select it here, notice the difference. So when you're working promoted bodies, you need to look for that also, okay? Anybody ever seen that? Get it to know. So when you're promoting a body, though, this is where I used a lot for weldment, because I would come in there, I'd have my master, you know, all these in here, wouldn't have the holes in it yet. And then I'd bring it over to here in a promoted body, and inside that promoted body, I would have my weldment as one piece, and then I'd come in there and put the blends or any other cutouts or anything I want to do at assembly level. Now, what you may want to do within the master file here, have some type of note to allow yourself to know, hey, this is also used in a promotion above. Make sense, guys?
Yep.
It does.
All right. So let's go to the very top here. So what I've shown you guys real quick, just to go through, we went in and we talked about design and context, part and process, and control structure. We then went into the geometry and we talked about the different options. From there, we talked about body versus wave. Promoted body versus wave. Interpart browser. I've shown you guys that, and the Interpart navigator. We talked about, like I said, the design and context. I went into this assembly here and showed you guys how you could make some mistakes. From here, we talked about part and process, wave engineering, and then we quickly went through the different things in the dialog box. With that being said, I'll open up the floor if anybody has any questions. Any questions, anybody?
Bryan, I have one question. Can you hear me?
Yes, I can hear you.
Yeah, Bryan. See, I have one question on the mirror body. Like you're shown like a before promotion body. So actually, mirror body is actually in the manufacturing concept. I have one doubt because generally mirror we won't use as per the standards of the customer or could be anything. But this mirror body will help us like in what way in wave geometry linker, because in the larger assemblies, we will create a master component and that master component will work for the LH. Suppose my RH is my master component, then I'll work as a master component, then LH could be the reference component, because we can't mirror it. Because I have a doubt, I wanted to like to clear. So that is where I am just asking you about this one mirror body you have shown to us.
So this mirror body here was components. And when I mirrored it over, I did mirror it over as components also. So if I'm not exactly following your question, but if I make a change in this one, it will make a change in this one here.
Yes,
this
correct,
is my master.
Because, yes. One is a master, but actually once we create a model and we'll create a drawing also. But the thing is, once we show the model for RH, so the same thing, mirror component, we will not work on the mirror component for the LH, because we say generally it is a we are using the wave geometry linker, because this is a master component, and as per the customer standards, because mirror they won't use, symmetry they will generally use. That's what I know, because I would like to know. That is the reason I am asking on the mirror body. So mirror body will not be used in my cases. That's what I seen. When I seen here, I would like to know about it. So that is the reason I'm asking.
Are you in a managed environment like Team Center?
Yeah, like automotive assembly is there. We do an RH.
There are some restrictions when you get into a managed environments. Some of it's got to do with your naming convention and stuff like that. You can all send this question to me, and I can, investigate more offline. But right now, I don't think it's something I could answer real quick and easy. Does that make sense?
Yes, Bryan. It makes sense.
Yeah.
Thank you very much. It's a very good thing.
There are some restrictions when you get in and you're working with components. If it was just a single body, not an issue. You would have a single body with a different name. When you're working with assemblies and you're working in a managed environment such as Team Center, then we get into naming conventions and some other things that we need to look at.
Yeah, exactly. You're correct. Because assembly plays a very vital importance. That is where wave geometry linker is very important there. That is very, very important. It's a very nice, Bryan.
Right.
Thanks to you, Bryan. Thank you.
All right. Well, thank you for the question. Anybody else have anything?
Bryan, can you say anything about how the wave linking should be used in the context of the product interface?
Can you give me an example? What you mean by that?
Well, I have a customer. I'm writing a custom checkmate check. They want the check to fail if the wave link is not linked to a product interface.
Product interface.
But I haven't done that much with product interface, so I wasn't 100% sure how.
Yeah, I'm not for sure what you mean by product interface also myself. I apologize. There's a bunch of features within NX and a bunch of tools, and I'm not familiar with product interface, what that term means.
Okay, so there's a way of selecting certain geometry as part of a product interface. You're supposed to, I guess, use it something like a wavelink or wavelink to that geometry, so that you can work on part of that geometry while somebody else is working on a different piece of the geometry.
I would have to see how that's set up to really be able to answer that.
All right.
Apologize off the top of my head. I don't know. Which company are you with, Rick?
Engineering Industries Excellence.
Okay, I'm not for sure if you guys are under our umbrella or not as our for maintenance. You can also, if you are, you can put that in as a ticket. If you are under maintenance with us. If not, you could always email me and I can look offline on that also.
All right.
Okay. Here, I'll actually give you guys my, oh, went too far. There's my email and information there if you guys need to get a hold of me. So with wave geometry, there's so much you can do, but there's so many ways you can easily make a mistake too. That's the thing that you need to watch out with it. But there is ways to fix it, now with the relinker. Any other questions?